Hello and welcome, curious minds. Today, we're journeying to the very edge of imagination, to a place where the private sanctuary of your mind is no longer secure. We're talking about a concept so profound, so powerful, it has the potential to redefine what it means to be human. We're talking about the neural lock. Imagine for a moment a technology that can interface directly with your consciousness. Not just to interpret your brainwaves or translate thoughts into text, but to go deeper. Imagine a key that can unlock the very vaults where your memories are stored. This is the core premise of the neural lock, a hypothetical device capable of not just reading your most intimate thoughts and experiences, but actively copying, deleting, or even implanting them. Think of your mind as the most complex and secure hard drive in existence. Your identity, your skills, your joys, and sorrows are the files written on it. The neural lock in this analogy is the ultimate rootkit, a tool that can gain administrative access to your very soul, with the power to rewrite the source code of who you are. This idea isn't new, of course. It's a ghost that has haunted our collective imagination for decades. A staple of science fiction that serves as both a tantalizing dream and a terrifying warning. In the film, we saw master thieves navigate the labyrinth of the subconscious, not to steal an object, but to plant an idea, a subtle but world-altering form of memory manipulation. We were captivated by the thought of a dream within a dream, but the true horror was the violation. The idea that someone could sneak into your mind and change your motivation without you ever knowing. Then there's Matrix, which presented a more commercialized version of this power. The ability to purchase the memory of a perfect vacation, a thrilling adventure as a secret agent without ever leaving your chair. It's an alluring fantasy, but one that quickly descends into a nightmare of false identities and manufactured realities. When your memories can be bought and sold, how can you be sure which ones are truly yours? The neural lock takes these concepts to their logical and most chilling conclusion. What if a rival could steal the memory of your brilliant career-defining idea right out of your head, leaving you with nothing but a faint sense of forgotten genius? What if a government could pacify a rebellious population by selectively erasing memories of injustice, or implanting a false sense of contentment and patriotism? The implications are staggering. A witness to a crime could have their memory of the perpetrator's face altered or erased entirely. A soldier haunted by the horrors of war could have their traumatic memories surgically removed, offering a cure for PTSD that is both miraculous and deeply unsettling. Does removing the memory of trauma also remove the lessons learned from it? Does it erase a fundamental part of that person's journey and resilience? This is the central paradox of the neural lock. Its potential for profound healing is inextricably linked to its potential for absolute control. On one hand, imagine the therapeutic applications. A student could theoretically download a complex subject like quantum physics, absorbing years of study in mere hours. A victim of a tragic accident could have the debilitating looping memory of the event softened, allowing them to move forward with their life. But every coin has two sides. For every life that could be repaired, another could be dismantled. Your most cherished memory, the day you got married, the birth of your child, could be copied and experienced by a stranger. A false, incriminating memory could be implanted in your mind, making you confess to a crime you never committed with genuine conviction. Where does the person you end and the person you've been to begin? This isn't just about changing what you remember, it's about changing who you are. This deep-seated desire and fear to control the contents of the mind is a timeless human obsession. From ancient mnemonic palaces designed to strengthen memory to 20th century psychoanalysis that sought to excavate it. The neural lock is simply the technological apotheosis of that long-held dream. But as we stand on the precipice of turning this fiction into fact, we have to ask, Are we ready for the consequences?
So, the neurolock sounds like something ripped directly from a sci-fi novel, a fascinating but ultimately fictional cautionary tale. But what if I told you that the foundational pillars for this very technology are not only being theorized, but are actively being constructed in pioneering neuroscience labs across the globe? The line between science fiction and scientific fact is becoming blurrier every single day. To understand how this is possible, we need to look at three key areas of research: neuroplasticity, brain-computer interfaces, and the game-changing technique of optogenetics. First, let's talk about neuroplasticity. For a long time, the adult brain was thought to be a static, hardwired machine, but we now know that's fundamentally wrong. Your brain is incredibly dynamic, constantly reorganizing itself in response to experience, thought, and injury. Think of it less like a finished stone sculpture and more like a living forest. New pathways like trails can be forged between trees, while old, unused trails can become overgrown and disappear. These pathways are the connections between your neurons, and the strength of these connections is the physical basis of memory. When you learn something new, specific neural connections are strengthened in a process called long-term potentiation. This is the brain's natural save function. The principle of neuroplasticity is crucial because it confirms that memories are not immutable ghosts in the machine. They are physical, malleable structures that can, in theory, be altered. Next, we need the hardware to interact with these structures. This is where brain-computer interfaces, or BCIs, come in. You've likely heard of ventures like Neuralink, which aim to create high-bandwidth connections between the human brain and computers. While mainstream attention often focuses on futuristic applications, the core technology is about reading and writing neural information. Current BCIs can already read motor intent signals from the brain with enough precision to allow a paralyzed person to control a robotic arm or type on a screen with their thoughts. This is the read function. The write function is also emerging, with technologies like deep brain stimulation using electrical impulses to treat conditions like Parkinson's disease by modulating neural circuits. A neurolock would require a BCI of immense sophistication, capable of targeting and interacting with specific, tiny clusters of neurons, the ones that hold a particular memory. This is where the third and perhaps most revolutionary piece of the puzzle comes in: optogenetics. This technique is as precise as it sounds. Scientists use genetic engineering to introduce light-sensitive proteins into specific types of neurons. Essentially, they install tiny, light-activated on-off switches onto the exact brain cells they want to study. By shining a laser of a specific color through a fiber optic cable implanted in the brain, they can turn these targeted neurons on or off with millisecond precision, without affecting the cells around them. It's like having a remote control for individual brain circuits. And this has already been used to manipulate memory in a way that is truly mind-boggling. In a landmark 2013 study at MIT, a team led by Susumu Tonegawa did something straight out of a sci-fi script. They took mice and, using optogenetics, identified and tagged the specific brain cells that formed when the mice created a memory of a safe environment. Then, they moved the mice to a different chamber and gave them a mild foot shock to create a fear memory. Here's the incredible part. While the shock was happening, the scientists used a laser to reactivate the tagged cells associated with the environment. They essentially linked the feeling of fear to the memory of the safe place. Later, when they put the mice back in the original safe chamber where nothing bad had ever happened, the mice froze in fear. They had successfully implanted a completely false memory. They made the mice fear a place that was, in reality, perfectly safe. This experiment is a stunning proof of concept. It demonstrates that with the right tools, we can identify the physical location of a memory and artificially reactivate it or even link new emotions to it, creating a new synthetic experience. The ethical implications are an abyss. The same tool that could one day target and deactivate the specific neurons causing a veteran's crippling PTSD could, in the wrong hands, be used to instill fear, obedience, or false loyalty. The power to edit the mind is the power to edit the very fabric of identity and society. This technology isn't a distant dream. Its fundamental principles are being proven right now, forcing us to confront one of the most profound questions we will ever face. The power to rewrite the mind is the power to redefine humanity itself, and the ethical blueprint for this future must be drawn now, before the technology writes it for us. Would you ever trust a technology that could alter your memories? Let us know in the comments. Subscribe for more explorations into the unknown, and we'll see you in the next one.